Right, let's look at the second type of asymptote, a horizontal asymptote. Consider the function x over x plus 2. From the previous video, x equaled minus 2 is a vertical asymptote, but notice the long-range behavior of the function. As x approaches minus infinity and plus infinity, f of x approaches the line y equal to 1. So we have a definition here of a horizontal asymptote. The line y equal to b is a horizontal asymptote of the graph of f when f of x approaches b as x approaches minus infinity or x approaches plus infinity. So here's our definition of a horizontal asymptote. Our rational function, you saw that definition earlier. N of x and d of x have no common factors. The graph of f has most one horizontal asymptote determined by comparing the degrees of n and d. Okay, if n is less than m, the graph of f has the line, the x-axis, as its horizontal asymptote. Notice 1 over x plus 2. Let's check some things out here. 2 can be written as 2 times x to the 0. So n is 2, m is 1, n is less than m, so y equals 0 is the horizontal asymptote. Let's look at another example. Let's suppose that f of x is x over x squared minus 3. N is 1, m is 2, n is still less than m, so notice y equal to 0 is the horizontal asymptote. Right now, if n equals m, then the graph of f has the line a sub n over b sub m as the horizontal asymptote. Look at my example there. A sub n would be 2, b sub m would be minus 1, so y equal to minus 2 is the horizontal asymptote in that one. Let's do a few more examples. A sub n equals 1, b sub m equals 1, 1 over 1 is 1, so y equal to 1 is the horizontal asymptote. Let's work another example so that you get good at this. F of x equals 3x minus 7 over 4 minus 5x. Now watch out, you don't always use the first thing written. A sub n is 3, b sub m is minus 5, so y equal to minus 3/5 is the horizontal asymptote. How about another one here? F of x equals x cubed minus 7x over 8 minus 3x plus 4x cubed. So a sub n is 1, b sub m is 4, so y equals 1 over 4 is the horizontal asymptote. Now, we have some other types of asymptotes when n is greater than m. Then the graph will have no horizontal asymptotes. If we consider f of x equal to x squared plus 1 over x, what we get is that y equal to x, notice the picture, is a slant asymptote. Now, it's still a line. However, if you look at x cubed minus x plus 2, then x squared minus 1 is a nonlinear asymptote. We actually have a parabola being an asymptote. We will look at these a little bit more in another section.